So we are in this book, Causal Inference in Statistics, and we are down in Chapter 3, and we're on question 3.4.2. Okay, so the way that this breaks down is we have this big long explanation or story, and then we're asked to do some thinking about it and answer some questions. So you can read this story for yourself, and I'll kind of give you the paraphrased version. So the person that's telling this story goes into a pharmacist, I guess, and trying to relieve some sickness that they have, and they see the medication that they want, and it comes in two versions. And one version is cheap, and the other version is expensive, $1 and $10. And he digs into this, and he finds out, well, the $1 version has been on the shelf for a while, so it's aged, and the $10 version is fresh. But the clerk mentions something a little bit interesting, and is really the crux of the questions here. He says that interestingly, the aged bottles, even though most of them, in fact only 5%, still have active ingredient, while the fresh bottles, 95% of those have active ingredient, the people that bought the aged drug got better at a better rate than the people that bought the fresh drug. Okay, so that's interesting. And so the narrator thinks to him or herself, what should I do about this? Should I buy the aged or the fresh? And then upon thinking about it for a while, even though more people that bought the aged drug got better, he decides to go for the expensive fresh drug. And he says, or she says, that they arrive at this conclusion based on these two assumptions right here. The first one being that the customers had no information about the chemical content of the specific bottle that they were buying, but just the price and the shelf age. Okay. And then second, that the effect of the drug was only due to its chemical content, okay, which I take to mean only active drug is making people get better. All right. And so now we are supposed to do these three things, A through C. Okay. So now this is about my third time trying to make this video, largely because I think that there is a confusing bit in the asking of this question. Maybe it could have been phrased a little bit better, but ultimately I think maybe trying to drive through any initial confusion is actually very helpful and instructive here. Okay, so so part A is we need to determine the relevant variables and describe describe the situation that's being above. We're supposed to describe it in a causal graph or a DAG. Okay, so this is already from the get-go, it starts to get just a little bit confusing here, right? Because we have variables like shelf age and price and drug potency and da-da-da-da-da. So let me walk you through what this DAG is doing. So what we're told is that there are drugs that have been on the shelf for however long, for a long time, or they're fresh, and that the shelf age is affecting both price and, I'm going to assume, drug potency, that the drug potency is decreasing over time. Okay, and so and we're told that the drug that any particular person selects is based on shelf age and price. Okay, and so the drug that they select is ultimately going to lead to recovery, and the way that it's going to lead to recovery is whether or not there was active drug in the pill that they selected. Okay, so that's all described in the scenario. What is, maybe with the exception of drug potency going down with shelf age, but I think it's more or less implied in the question. Okay, what is not discussed in the question, and in fact I think is actually forbidden by the question, is this guy right here, is this disease severity. Okay, so by assumption 1 up here, it says that customers, yeah, by assumption one, it says that customers are only picking the drug based on uh, based on the specific bottle or I'm sorry, based on the price and the shelf age of this specific bottle, right? That's why we have arrows in price and drug selected. Okay, um, but uh, but I have to believe that another piece of information that every individual has is how sick they feel, the disease severity. In fact, I can't make sense of this uh, unless they also know about their disease severity. Okay, so I am putting this in here tentatively, and we will look at this question through both lenses, whether or not disease severity is is a proper part of this DAG here. Okay, there's another confusing bit about all of this, again having to do with assumption one, where again assumption one is that the drug that is selected is based only on shelf age and price. And to me, the confusion comes because I would have to imagine that any thinking agent uh, would understand that the price and the shelf age are somehow related to drug potency. And so it's very, very tempting to also have an arrow going from drug potency to drug selected. But we're going to ignore that and just go with what's spelled out in the question. Okay. Now, the next part says to construct a data set compatible with the story and the decision to buy the expensive bottle. Okay. So this question, as I went through and tried to answer this question, this is what made me believe more strongly that disease severity is actually supposed to be in the answer, even though we're kind of dissuaded by the wording of the question to put it in there. Why do I say that? This section of the book has to do with exploring the front door criterion, the front door adjustment. Okay. Well, look at what happens when we put disease severity into the question. All right. We have, if we look at just this triangle right here from disease severity, drug selected, active drug consumed, recovery, we have a situation where we can apply the front door criterion. Now, every time that the book has asked us to construct a data set, we could more or less repurpose a data set that was given previously in the chapter or in that section there. Okay, and so here I'm just repurposing the data set from table 3.2, which is a data set that gave us that helped explore this front door criterion, and it had to do with smoking and tar deposits and I think lung cancer. Okay, so I'm just simply relabeling and maybe moving around a few things the table 3.2 in the book. Okay, so there's that. Okay, now finally in part C we are supposed to determine the effect of choosing fresh versus aged drug by using assumptions 1 and 2 given as well as the data given in part B. Okay, so what this is asking us to find then is the ACE. What does ACE stand for? It stands for average causal effect. Okay, and so that is going to be the probability of recovering given due fresh. Oh, I need a parentheses in there. Let me pause that. So anyway, the probability of recovering given that we do fresh minus the probability of recovering, given due aged. Okay, so fresh drug versus aged drug. Okay. So now if we take assumption 1 seriously, in other words, that disease severity is not playing any role here, well then my average causal effect is just the observed probability of recovery given fresh minus probability of recovery given aged, right? And so I believe I've done that right, but perhaps you can go back to my DAG here and notice that there's no back doors into shelf age. So in other words, there's nothing. If we assume that disease severity does not belong in here, then there's nothing to confound the relationship between shelf age or price, drug selected and recovery. It's just the observed difference in probabilities. So if we take that seriously, well then the ACE just becomes the observed difference in these probabilities, and that comes out to negative 75.5%. In other words, this would suggest that the people that take the fresh drug are, less likely to recover. Okay, and this is indeed what the clerk told us, but it goes against, how we think pharmacology should work. So we should probably take seriously the idea that disease severity belongs in this story here. And because disease severity probably belongs in this story, we are able to use this front door adjustment just in this little triangle right here. These are the only things that are relevant here, is this little triangle here. Okay. So now when we do that, I've made a, oh no, that's fine. Okay. Let me adjust something. Okay, now it's a little bit easier to see. So now our average causal effect is, P recovered due fresh minus P recovered due aged. But now the due expressions here are actually doing some work here. Okay, and so we're going to compute the front door adjustments for these guys here. And just to reduce my typing, so I'm not having to type all of this every time, recovery is going to be coded as y sub 1 or y sub 0, where y sub 1 is going to be recovered and y sub 0 is not recovered. And then x1 and x0 are going to be, x1 is going to be the expensive drug or fresh drug, and x0 is going to be the cheap or aged drug. And then remember, in the front door criteria, we also have z, okay? And z is going to be whether or not the active drug was consumed or the inactive drug was consumed. Okay, so z1 is the active drug being consumed. All right. So we need to find both this expression and this expression, and so that's what we're doing here. Okay. Now this is how we applied the front door criteria. So earlier in this playlist, we went through and broke down how the front door criteria makes sense, and so I'll just refer you back to some of those earlier videos or to the book to make sense of that. But this is the expression, and if I've done all of my math right, then this is the probability of recovering given that we take the active drug. Okay, and again, what this is accounting for, well, disease severity. Okay, and now if we don't take the active drug, let me clarify something really quick. I just said that this is accounting for disease severity, but it's doing it, recognize that it's doing it indirectly, right? We don't, disease severity is not, it's an unobserved variable, hence the kind of grayed out appearance here. But by using the front door criteria, we are, in essence, adjusting for the fact that disease severity is playing a role here. Okay, and so now we get probability of recovery given doing the aged drug. Okay, and we get this. So if we just subtract this from this, right, we get, a positive probability, not overwhelmingly positive. Doesn't look like the drug is doesn't look like the drug is really all that effective, but it is greater than 0. So we would say that the fresh drug is doing a better job than the cheap drug. Okay, that is it.